Alright, so we're trying to work on the problem. The problem states that we have a mass of 4 kg, which is rock, attached to a spring, and the spring is swung in a circle of radius 6.5 meter. The spring exerts a constant force of a constant magnitude of 620 Newton. And then we're asked to find the velocity of the rock with which it is going around, and then the relaxed length is given, and then we're asked to find the stiffness of the spring. Now, let's get started. The given things we have is first the mass of the rock. The mass of the rock is this object, which is 4 kg. The second thing given is the radius of the circle, with which it's going around, that is 6.5 meter. And then the force exerted by the spring in a constant magnitude, which is F net, is given, and the relaxed length of the spring, 5.7 meter, is given. Again, the condition of the problem is the rock is attached to the spring in the outer space, and the spring is swung around in a circular motion. And what are we trying to find? Well, we're trying to find the speed of the rock with which it's going in a circular motion and the stiffness of the spring at the same time. Alright, towards the problem. We know the force exerted by the spring, F net, is given by K times delta L, which is where K is the spring stiffness and delta L is the change of the length of the spring. We'll need that later, so let's say that equation 1. Now, let's draw the forces on the object going around. The net force is directed towards the center, and it's given by F net equals dP over dt. Now, since this is a circular motion, an object going in a circular motion, right here, we can write dP of dt as P V over R. Now, for this can be further derived, since P is m times V, we can further derive this as mv squared over R. Now, let's name this equation as equation 3. And just for extra information, if there was angular velocity given instead of the real velocity, we could have broken down this as m omega square r because v equals omega r. Now, what are we interested on? We're interested on finding v. So we have F net given, we have mass given, we have radius given, so now let's find a v. Now to find a v, what we can do is we can combine these equations. See, right here we said F net equals dP over dt, and dP over dt, since it's a circular motion with a constant force and a constant speed, is mv squared over r. So now let's say mv squared, now we can say mv squared over r equals F net. So doing that, F net equals mv squared over r. F net is given to us, which is 620 Newton, mass 4 kg, velocity, that's what we're trying to find, radius 6.5 meter. Now to solve for velocity, once we just move velocity to the left and then multiply 620 by 6.5 divided by 4, which gives us 1007.5, and then taking the square root of that, we get 31.74 meter per second. Now right here, just to make sure, let's check the unit. 620 Newton is the force, which is kg meter per second squared. Now, and then we have this distance, which is a meter, and then the mass divides, which is a kg. Now kg and kg cancels out, leaving us meter squared per second squared, which is exactly what we want because we're doing the square root to get the meter per second. So this is how we can find the velocity of object going in circular motion if we have the net force given and we have the radius of the circular motion given. Now the second goal is to find the stiffness of the spring that's to which the mass is attached. We know that force of spring is K times delta L, where K is the spring stiffness and delta L is the change in length. Now total force is given 620 Newton. We're trying to find K. Delta L was what? Change in length. 6.5 was the length when it was going around. Its relaxed length was 5.7. Now to find K, we just divide 620 by the difference, which is 0.8, and we get K equals 774.93. Again, check the units. Force is Newton, and this is the distance, which is meter. So we find K equals this Newton per meter. Now this gives us a really important concept of object going in a circular motion. Whenever there is object going in a circular motion with a constant force and the constant speed, then we can say we can find the net force, we can find the time period that it takes going around using the formula F net equals mv squared over r, and that is exactly what we used here to find our answers. Thank you.